All right, we are learning about exponential functions, okay? Our learning goal is I can graph exponential functions, identify key features, determine domain range of exponential functions using inequalities, and we'll do our DOL. So here's an anchor chart of exponential functions. It's just a graph or curve that curves up, okay? And here are some key features or key components of exponential functions. You have your y-intercept is where it crosses your y-axis. And this is your horizontal asymptote. We can think of it as the bottom floor, but it's the invisible line that you would draw that shows where this graph would be approaching the y value here. So where does this graph kind of flatten out? And it flattens out at around -4, okay? Approximately, so your horizontal asymptote will be y equals -4. Again, it's the invisible line that you would draw at the bottom or top of the curve where it shows it's flattening out, where it's starting to approach a zero slope, okay? Where it's starting to slope out at 0. Starts to flatten out, and it looks like it's around this area right here where it starts to flatten out. And it's around y equals, never x equals, but always y equals -4 for horizontal asymptote. You need to know the formula for exponential functions. So the total amount equals principal times your rate times your time, or it might be an x up here. Your principal, another term for principal, remember this, this number right here in the beginning is the same thing as your y-intercept or your starting point, your initial values. They're all synonymous, okay? So whatever number you see here in front of the first number that you see here is always your initial, your starting point, your principal amount. You see this formula in banking, you'll use it in banking and investment. If you are going into finances, want to own your own business, marketing, doing stats, you need to know this formula like the back of your hand. This is your initial amount, okay? Your range is where the starting point of your curve, or like where your lowest value of your part of your curve is, and then the highest point of your curve. So the lowest part of this curve, the y value is around -4. That's where it's the lowest at -4. And then the highest, well, this curve keeps going. So the highest peak will be infinity. So it will be y is greater than -4. Anything -4 and above is your range. Now your domain is the opposite. The domain is x and your x values, so your lowest x over here and your highest x over here. So your lowest x, this curve started right here at around -7, right? And this curve keeps going and 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 going along all these x values here. So it's infinity. So it's anything that's greater than -7 along the x-axis. So those are some key features of exponential functions. So now we're going to go ahead and go to our worksheet and answer some questions, and then we're going to learn how to graph a function and see our key features that way visually, okay? This is exponential function. So here you have a graph. The graph, we read from left to right, so that means the graph is going up. So this one will be exponential growth. It's asking for the y-intercept. Y-intercept means where this graph intercepts the y-axis. It intersects it right here at -1. That's 0, -1. So your y-intercept, you could say, is y equals -1, or you might see it as an answer choice as a coordinate. Okay, 0, -1 is the coordinate. 0, -1. Your horizontal asymptote is where you draw an invisible line at the bottom of a curve. If the curve was like this, upside down, then it'll be the top of the curve, the ceiling right here. So that will be your horizontal asymptote. is the line that touches the bottom of the curve. Horizontal asymptote is this line right here, okay? That horizontal line crosses through which y value? It crosses through your -5 y value, okay? So your horizontal asymptote, you would draw the line that is horizontal to the bottom where that curve flattens out right there. So it's the invisible line that approaches where that curve begins to flatten out, and that that invisible line is at approximately -5. Any horizontal line crosses which axis? Does it cross the x-axis or does it cross the y-axis? This is y, this is x, right? So any horizontal line cuts through the y-axis. So your horizontal line, take note of this, is always y equals. If you see horizontal asymptote as an answer choice is x equals something, this is not a correct answer because horizontal lines are always y equals something, okay? So your horizontal asymptote, this one in particular, cuts through at -5. So y equals, not x equals, it's always y equals. Take note of that. It's always y equals -5. Your range is the lowest point of your curve to the highest point of your curve along the y-axis. The lowest point is down here, which is at -5. Okay? Your highest point, this curve keeps going up, 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 up. It looks like it might stop there, but there is no circle or any kind of point to show it stopping. So we can naturally assume that it keeps going forever and ever and ever and ever. So your range is -5 to infinity. We can write that as y is greater than or equal to 5. So you might see it either way, but this is how you probably will see it for this class. Y is greater than or equal to -5. -5. Here's -5. That's where your curve starts. Is this curve going below -5? Or is this curve going above -5, right? It's going above it, so it's greater than, okay? That's how you would do these problems here. Do one more quick one here. Or a couple more quick ones here. So this one, again, we read from left to right, right? So from left to right, is this curve going up or down? Exactly, it's going down. So it's exponential decay. Exponential decay. This curve here, it intercepts which y-axis or which y value. Your y-intercept is where the line or the curve intercepts or crosses your y-axis, this axis right here. So where does this curve cross this y-axis? It crosses it right here, which is 1, 2, 3, at 3, right? 1, 2, 3. So your y-intercept is y equals 3, but you most likely might see it as a coordinate. So what is the coordinate for this one? This point right here, well, it's 0, 3, right? 0, 3. Your horizontal asymptote, again, is where? Is your horizontal asymptote up here? Is it here? Is it right here? No, it's at the bottom of the curve, right? Your horizontal asymptote is the line, the invisible line that you would draw or notice that almost touches the bottom of this curve, or if it was inverted, the top of the curve. But this is the bottom right here, and it goes all the way to which y value? What is this y value right here? That horizontal asymptote crosses through y equals 2. Y equals 2 is your horizontal asymptote. Is it x equals 2? No. Why? Because it's crossing which axis? It crosses the y-axis, exactly. Your range is your lowest and your highest y value, okay? Remember, your domain is your lowest and highest x value, and your range is your lowest and your highest y value. Write that down if you don't know that. Okay, so what is your lowest y value along this curve? Well, the lowest point, the valley, right? The valley, not the peak, but the valley is down here at which value? At 2 as well, right? Your horizontal asymptote and your lowest part of your range is the same. It's your bottom line. Your bottom line, right? Your lowest point, the highest point. We can assume that this curve keeps doing what? Keeps going, right? So it's anything above 2. So 2 to infinity, okay, will be your range. 2 to infinity, or we could write it as y, range is y, is greater than or equal to 2. It's not going less than 2, it's going greater than 2, right? So that will be your answer right here. Now, it might ask for a domain, for example. Right here, what is a domain? Now here we see 2 points, meaning this curve does stop. So domain is x or y? It's x. So what is your lowest and your highest x? Your lowest x that you see along this curve is this, you're looking at the x-axis, right? So make sure you're looking at the right axis. Amongst these values, which value is your lowest x along the curve? Well, it's this one, -1, right? Your highest is at 3, okay? So your domain is anywhere between -1 and 3. -1 and 3. That looks like these two, right? Can't be C, it can't be D. So now we would look at x and y. Domain is x or y? Domain is x, exactly. So it'll be A. Okay, it's greater than or equal to. Remember, open circle is greater than or equal to. Closed circle is greater than or equal to. Sorry, open circle is greater than or less than. Open circle is greater than or less than. Closed circle is greater than or equal to. And then less than or equal to. If you shade those lines in and shade that circle, and you should remember which one goes with which one. These points are closed, so it's one of these kind of symbols with the line underneath of it, okay? That's an example of domain. And now I'm going to show you how to graph an exponential function and be able to answer questions about this equation, okay? All right, now I'm going to go ahead and show you how to graph this, guys, because it's asking questions about this function. It might say which statements or which of the following are true, or select all that apply. So you want to go through each of the answer choices and see which ones could all be true. So you would go to Desmos here, Star Desmos, and you would put in the equation, which is y equals 8 times 0.25. What do we learn about this equation here? What is this number? What does that number represent? Remember, A equals PRT, right? P times R to the T power. So it looks like this, right? We can think of PERT. That first letter represents what? We learn about principal, right? Your principal. What is another word for principal? What did I just show you guys? Principal is your starting value or your y-intercept, right? So we'll put this into Desmos and you'll see what I'm talking about. 0.25. To raise it to the power, you do shift and then 6. It's that little arrow there. Or you can do, click on your tray here. and do a to the b power, that'll raise you up top there and put your x, okay? And there you have your curve, okay? So 8.25, 8 times 0.25 to the x power will give you an exponent, okay? So here's your curve. So you can answer questions about this curve, like what is your y-intercept? So where does this curve cross your y-axis? Crosses it right here, right? At 8. What are the odds? Tells you right there as well. So your y-intercept is definitely 0,8. So that's definitely one option. What about your asymptote? We learned the horizontal asymptote. They forgot horizontal. Horizontal asymptote is what? It is your bottom line, or where that curve begins to flatten out. So this is your horizontal asymptote right here. This line is approaching which y value? It's approaching 0, okay? That horizontal line is starting to cross through 0, right? What did I say about horizontal asymptotes? It's y equals, never x equals. So it's not x equals, it's y equals. So that can't be it. It's close, but that letter is wrong, because any horizontal line crosses through your y-axis, so it's y equals, not x equals. So it's not h. It's asking us for the x-intercept. What is the x-intercept? Well, let's look at our graph. Does this curve ever cross your x-axis? From what we can see, it does not cross it. It's flattening out. So it never crosses it. It almost touches it, but never actually dips down to cross. It has to cross the x-axis. So if it doesn't cross, there's no x-intercept. So write that down. If it doesn't cross, that equals no x-intercept, okay? If it doesn't cross, there is no x-intercept. Remember that. So it's not F. What about J? Does this graph include point 2, 1? Is this point 2, 1 on this graph? Well, let's look at it. Let's zoom in. You would zoom in right here. And let's look for 2, 1. 2, 1 is right here, right? 2, 1 is right here. This point 2, 1 isn't on this red curve. No, it's right above it. It's right above it. So that's not true. It's close. So our answer would be G. So that's what you would do for questions like that. You would just put this into Star Desmos and visually look at it. If you have any questions about this quick little lesson, then you can come for tutoring or look at other videos online or ask me in person. You have all kinds of options, but that is exponential functions.